Okay, let's begin with this topic. This topic is about functions. Okay, so what is a function? In mathematics, a function is a special type of relation. Okay, so it's a relation that we are going to assign between two sets. Okay, the first set, that is the input set, that we are going to call the domain, with a second set of numbers that we're going to assign with the name of range. Okay, so a set of numbers, for example, a group of numbers, I don't know, 1, 2, 3, and 4. Okay, so this set of numbers is going to be related to exactly one element of the other group of numbers. For example, 5, 7, 9, 11. So we are going to pair these two sets. The 1 is going to go with the 5, the 2 with the 7, the 3 with the 9, and the 4 with 11. Okay? So what is a function? In simple terms, we can say that a function, okay, a function assigns one output value, okay. Usually this output value is going to be the letter y, okay, for every input value, and the input value is usually the x. Okay, so the input is the domain, we're going to say the x, and the output or range is y. When when the number 1 enters to this rule or function, okay, this is the input, where the outcome is going to be a 5. Okay, for example, we need the rule. Okay, we need to say how this machine works. Okay, so for example, f of x, this is called f of x, okay. F of x is, I don't know, for example, 2x plus 3. Okay, that means that every time a new x enters to this rule, is gonna be multiplied by the number 2, and then we are going to add the number 3. So when the 1 enters here, 1 times 2 equals 2, plus 3 equals 5. Okay, so when x is 1, the function or the outcome is a 5. The 1, okay, for example here, the 1 goes with a 5. Okay, when the number 2 enters, 2 times 2 equals 4, plus 3 is a 7. So when the 2 enters, a 7 comes out. Okay, and so on. 3 times 2, it equals 6, plus 3 equals 9. And 4 times a 2 is an 8. 8 plus 3 is an 11. All right? So this is a function, okay? Is a rule that assigns one output value for every input value. All right? Okay, let's move on. What are the elements of function? Okay, the elements of a function is, for example, the domain. Okay, so how can we describe the domain? We can say that is the set of numbers. Okay, the set of all possible values. So possible, yeah, input values. Okay, and the range is the set, the group of all possible output values. Okay? This in a graph is going to represent the extension in the x-axis, and this the y-axis. All right? We need the rule of assignment. Okay, what is the rule of assignment? The rule of assignment is expression, okay, expression or formula, that defines or that tells us, defines how uh, how inputs are transformed into outputs. All right. Okay. So what else? We have also the variables. Okay, we have the independent variable is usually the letter x. Okay. So what is the independent variable? Okay. So these represent the cost. What do I mean with the cost? And of course, the y variable, the dependent variable, is the effect. Okay? What does this mean? I said already that the x is part of the domain and the dependent is part of the range. Okay? So, the independent is the cost. That means, for example, time. For example, okay? I don't know. Every second that happens, okay, I spend money. Okay, so this is the or for example, profit, what I win. I have a company, and for every time, for every hour, okay, every hour that happens, okay, I'm going to earn any quantity of money. Okay, another example, I don't know, for every degree or calorie that enters to the system, the output, the dependent variable, it's going to be the temperature, for example. Okay? If I add any energy or calories to a system, the temperature is going to rise. Okay? Or if I take away some calories, the temperature is going to go down. Okay? So the independent variable is the cause and the dependent variable is the effect. Okay? So how can I describe this graphically? Okay, so we have graphs for a function. How can we determine if a graph is showing us a function or just is another relation? Okay, for example, I'm gonna call this the first graph and this is the second graph. For the first graph, I can say that when x, this is x, when x has a value of 3, okay, the function f of 3, okay, equals 3 in this case, okay? Another example, when the x equals 1, f of 1, the function equals 0.5, okay? When f of x equals minus 1, okay, I don't know what happened over here, okay, minus 1, the function of f of minus 1 equals 1, okay, is the height, okay? So, this, for every input value, we have only one outcome, okay? For every x that enters, I have only one y, okay? In the second, okay, this is a function. Yes, this is a function. Yes, it is. For the second one, for example, when the function, when enters an x of with a value of minus 2, okay, the function or these relationships is gonna have an outcome value of minus 1, okay? But when we come, when the input value equals 2, we have two possible values, okay? This is a minus 3 and a 1, okay? We have two different values. So this is no a function. No, it's not a function. All right? So I can determine if a graph, okay, corresponds, or if a graph is describing a function using a very simple rule, that is the vertical rule, okay? If I can draw a line, a vertical line, and if the line is touching 2 points or more, it's not a function. If the line, a vertical line, is only touching 1 point, this is a function, okay? For every part of where I can or I want to check it, okay? So it's only touching 1 point. And in this case, different lines are touching more than 1 point. So let's check this. The first one, is this a function? If I draw a line here, only touches one, okay? So this is a function. Yes, it is. If I draw a line here in the second exercise, it touches 1 point. But if I move just a little bit, this line touches 2 points. So immediately I can say, no, this is not a function. In this case, we are showing that every line touches only 1 point. So yes, this is a function. And in this case, again, I'm touching just 1 point here, but in this case, I'm touching 2 points. And in this part, I'm touching 1, 2, 3, 4 points. So no, it is not a function. Okay? So graphically, we can say that the graph is representing a function if a vertical line is touching only 1 point of the function. Okay? So let's move to function modeling. Okay, how can we get a function from a real life situation or a real life context? Okay, first we need to identify variables. Okay, we need to collect information, collect data. We need to register to plot the points on a graph or table. Then we need to find a pattern, okay, or trend, and we need to create an equation. For example, it says if a car rental costs $50 plus $10 per hour, what is the cost function? Okay, if a car rental, okay, costs, the cost, okay, is the function. The cost is going to depend. This is dependent of time. Okay, so this is a function. Okay, we are going to say, because what is a cost function? This is going to be our dependent variable. Okay, we are going to say c of x, c of h, because this is going to depend of the time, and the time is hour. So this is our independent variable, and this is going to be our dependent variable. All right? And we need information. For example, hours and cost. When I am renting, just because of the action of renting the car, there's no hour that has occurred. So when we have 0 hours, the cost is going to be $50. But I know that 4 hours later, for every hour that I am using the car, I'm gonna pay $10. So I'm gonna pay 10 times 4. Okay, 10 times 4 is 40. 40 plus the first 50 is $90. Okay, so we can say we are moving here. Okay, if this is moving for 4 steps, these are moving 40 steps. Okay, so for every step, I'm moving 10. This is because of the $10 per hour. Okay, so what is the function? The function is the cost equals 50 plus 10 times the hour. Okay? 50 plus 10 times the hour. This is our function. Okay? This is modeling. Modeling is getting the rule, okay? The rule of assignments in Spanish is la regla de correspondencia of this, okay? How the context is working, how am I going to pay for it, okay? Now we have the function evaluation. To evaluate a function means to substitute, okay? To substitute a specific input value into the function and calculate the output. For example, with this, in this case, the cost depends on this rule, okay? So when we use a car for 2 hours, how much money are we gonna pay? So it's 50 plus 10, and the hour, okay, now this value is 2, okay? I'm going to substitute the age for a 2. We multiply 10 times 2, it's 20, 20. 20 plus 50 equals $70. Okay, when the hour is 5, what is going to be the cost? 50 plus 10 times the hours that are 5. So 50 plus 10 times 5 is 50. 50 plus 50 equals 100. Okay? Now, then we have f of 0, now z of h. So we're going to use this new rule. In this case, we have f of x equals negative x squared plus 3x plus 1. Okay? So we're going to substitute every x with its input value. In this case, it's a 0. So negative, parentheses, 0 squared plus 3 times 0 plus 1. This equals negative 0 plus 0 plus 1 equals 1. All right, let's check the next one. Minus the value, okay, the value of x squared plus 3 times the value of x plus 1. The value of x in this case is a 3, so the order of operations tells us that we are going to use the power first, okay? 3 squared is 9, and then the multiplication, 9 times a negative, it's negative 9, okay? Plus 3 times 3 equals 9, and then plus 1. Negative 9 plus 9 is 0, 0 plus 1 is 1, okay? Then f of minus 1 minus 1 squared plus 3 times minus 1 plus 1. Okay, negative 1 squared is positive 1. Positive 1 multiplied by this negative is negative 1. Negative 1 times a positive 3 is negative 3 plus 1. So negative 1 with its opposite equals 0, so the result is negative 3. So this is evaluation, okay? This is a function evaluation. So this is the first part of this topic. So I want you to copy these notes and please upload them to the Teams assignment.